Hello Java warriors, welcome back to the channel. So today we'll be proceeding with variables and data types. So before proceeding, I want you guys to please subscribe, like, and be with me in this video. So let's get started. So guys, have you ever wondered how Java is dealing with numbers, words, or just true false switch? So if you can see that there is 1, 2, 3 are the numbers, welcome, subscribes, and likes are the words, and true and false is there, right? So how Java knows that these are the values that Java need to proceed, your code need to proceed with? Okay, so basically these are variables. So what are variables? A variable is basically a container. It holds data while your program is running. Think of it like a label jar in your kitchen, right? You have two different jars, which is of sugar and coffee. If you want to store sugar, label it sugar. Want to store coffee, label it coffee. So in Java, our variables look like this. How? This int age equals to 25. So here int is basically your data type, age is your variable name, and 25 is the value that it's stored. So you're literally telling Java, hey, store the number 25 in a variable called age that can hold integer. So this is how you will be creating a variable, and this variable is basically holding the values that you will be providing to Java. Okay, so there are few rules of this variables naming convention. So you can see that it start with a letter A to Z or capital A to Z, or you can use dollar sign, or you can use underscore also. Can't use keywords like int, class, static as names, because int statics are your data type and class is also your data type. So you cannot use it like this. You use these keywords in your variable name. So be descriptive, use user age instead of using just you. For example, you have written here int age equals to 25. So instead of writing it like int a equals to 25, you are writing it as int age equals to 25. So it is descriptive. It means you are telling your user that, hey, this is the age you will be giving, not any random value. So you need to create variables like this. So let's proceed further. So now, as you can see that we have declared in the previous slide int age equals to 25. So that int was your data type. So which type of data is your variable is going to hold? So there are two main types of data types in Java: primitive data types and non-primitive data types. In the diagram, if you can see that there are four subtypes in primitive data types. We'll be learning it one by one. So there are integers, which is containing byte, short, int, and long. There is floating point, which is your basically decimal value. After, if you have any value with the decimal point, so this is basically your floating point. So float and double as they are. Character is basically your A, B, C, D, E, F, G, any character you'll be having. And boolean is basically true and false. It is telling you the value of only true and false. And here are non-primitive data types, that is your string object, array object, list object, set object, stack object, vector object, or the dictionary, and all user defined classes that you will be declaring. These are non-primitive because these are user defined. Okay, so let's proceed further. So let's go with the primitive data types. In Java, primitive data types are the basic building blocks of data. They are not object, they hold simple raw value directly into the memory and are fastest to use. Directly into the memory means whenever you will be declaring a variable and assigning a value to it, this variable is going to store directly in the stack area of your memory. So you'll be seeing the memory management in the JVM lecture, so that I'll be creating a different video on it, so that you will check there only. But as of now, the in primitive data types is going to be stored in stack memory of the area, right? Stack area of your memory. Now you can see that I have created a a method, that is public static void main, and like count equals to 0, boolean user hit like equals to false. So that means I have created a variable like count. which value I have already assigned as 0 and is of data type integer, because I wanted to have this like count from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And boolean user hit like, which is true false. If you have hit like button, that is true, and if you don't like the video, that is false. And now we can see that int happy like equals to 1. If you like the video, the happy like count is going to be 1, right? So as of now I have created it 1 because I like my videos. So if user hit like equals to true, that means you are checking if it is true or false, user like your videos or not. If user like videos, that means like count is going to be increased. So if like count is greater than happy like, that means hit subscribe to support Trails of Tech. So that's the simple thing that I have used. But yeah, this is the main program. Here I want you guys to explain, understand the primitive data type. So like I have used int boolean in that as in primitive data type. So here are few data types and the explanation to that data types. So we have data type as boolean, which size of 1 bit. Boolean always take 1 bit in size. That's why all these things are stored in stack memory, because they have the constant size. And the default value of boolean is false. It store true or false value, right? Now we have second one is byte. So this is 1 byte, or 1 byte is equivalent to 8 bits. So this, its default value is 0 and stores whole numbers from 1 minus 128 to 127. So whenever there will be any number which is increasing from 127, so Java internally do its twos component that we'll be understanding in an with an example in the next slides. Okay, so now there is a short which is of 2 bytes equivalent to 16 bits, and the default value is 0, which is store whole number from minus 32,768 to 32,767. Likewise, int, long, float, double, and character will be having, and all these having this number of size like 4 byte, 8 byte, 4 byte, 8 byte, and this is storing the numbers from there to there. So I'll be showing the slide in this videos in this video, so you can check this slide out. Okay. Now we'll be understanding the non-primitive data types. So non-primitive data types are user-defined data types created by the programmer. What is user-defined data type? Like you have created a data type, such as you have created a class named laptop, and you have created the object of that class. So that object is basically your data type, or your class is basically a data type. You are creating an object of type class. So that's why it is a user defined data type. So okay, so the programmer and used to store multiple values or define complex object. Okay, so we'll see in the example, by example. So these are also called reference type because they store reference memory addresses to the actual data. So they don't store the actual data, they always store the reference to the memory address of the actual data. Okay. So these are the non-primitive data types, which are string, array, list, set, stack, vector, dictionary, all user-defined classes, extras. Now I am giving few of them example. So that string, if you can see, string name equals to TrailsOfTech. So this is the entire string, a sequence of character basically. Now the array, int array like count. Now you'll see this int is basically your primitive data type, but now you have created array of it. So this is the array of integer you have created. This is your own user defined data type you have created. So that's why it is non-primitive now. So store multiple values of the same type in array. And the class I have created as TrailsOfTech class I have created, which is a blueprint for creating an object. This is also a user defined class. That's why it is non-primitive. Interface also you can create by yourself, a contract that class implements. We'll be understanding about the interfaces in the different lecture, that you will understand how it works and what it is. Enum also the same, fixed set of constant values, which is not going to be changed, such as Monday, Tuesday, Wednesday, etc. The name of the days. And the object is here, then object obj equals to new object, the base class of all classes in Java. Okay, so now we'll proceed further. So we have typecasting also in this session. So what is typecasting? So typecasting is converting one data type to another data type. If you wanted to convert your integer value to double, so that you can typecast. If you wanted to convert your double value to integer, that also you can typecast. So here you can see that there are two types of typecasting: implicit typecasting or explicit typecasting. So autonomic type conversion is there. So you can see that widening means implicit typecast. That means if you have declared any variable and you have assigned that variable to the typecasted variable, so Java internally typecast it. You do not need to write explicitly. You do not need to give the data type of that converted variable, right? So if you can see in the example that int x equals to 10 and double y equals to x, I have directly assigned this x to y. So this is basically implicit typecasting. So int is converted to double. And if you can see that double z equals to 5.9. So int t equals to int z. So this int I have given as an explicit data types. I wanted to have this double into to type of integer. So that's why I have given it as an int. So that is basically your explicit typecasting. So be very careful. You might lose data during the explicit typecasting. So how you will lose data, that we'll be seeing with an example. So here you can see that the implicit typecasting, basically it is for the greater values like byte to short, short to int to long, long to float, and float to double. But in the explicit is basically your reverse direction: double to float, float to long, long to int to short, short to byte. So now we'll be seeing it by an example that how the typecasting is work and why you need to be very careful while explicit typecasting. Because when you do explicit casting, you are manually converting a larger data type to a smaller one, and that can lead to data loss because the smaller type can't hold the entire value. Understood. I think I need to go with an example on that part. So let's check with the example. So I am doing these two things, converting double to int and large int to byte. So let's go with example. So let's try to convert the double to integer. So I have taken a double value, that is pi value. You can say that 3.14159, that is the standard value of pi. Now I want this pi to be my converted int value, that will be converted int. So here I wanted to typecast it. So I'll be writing int in the parenthesis, what I wanted to typecast the pi value. So I'll be writing pi after the int. Now I'll be doing this as out. I wanted to have this converted value. So let's see what it is going to be returned. So this converted int I'll be printing. So let's check what it is returning. So I believe you will lose the precision value. This 0.14159 is not there because it's converted to int. So it is taking the round figure. So this is called the truncation of your integer value. So internally Java work like this. It truncate your uh, precision value, and it's returning 3 only. So that's why while using the explicit type conversion, you need to make sure you are not losing any value. So use it carefully. Now we'll see with the another example that I'll tell you about the. I wanted to convert the big integer value to a byte. So let's do it. And I wanted to have the big value. Big value. I want this big value 150. Let's taking an example of 150. Okay. So I want it to convert to byte of small value, right? So here what I wanted to typecast in which type? Byte type I wanted to typecast. So I'll be writing it here. What I wanted to typecast, this big value. So that will be here. Now I'll do simple as out. So with this simple as out, the system.out.println, it is simply printing the value on your console. So what it will, what I wanted to print, the small value. Okay. So I'll be writing it down, right? There's a small value. Okay, now run the program. So what it is going to return? I think it is going to return two's component. So yeah, here is -106 because the byte can only range up to -128 to 127. Now you can see there this 150 is the larger than 127. So what it will do, what Java implicitly do, it will do the two's component of this value 150, and after the two's component it is going to return you this 106. So that's why you are losing your original value. So that's why I'm telling you, be very careful while doing the type conversion. Okay, so that's all about the explicit type conversion we have learned today. So we have learned that what variables are, basically a container which holds your value. How to name variables, you can use A to Z, small case and uppercase, and a dollar sign and an underscore, and it should be descriptive. 8 primitive data types, that is byte, short, int, long, float, double, and non-primitive data types such as a string and all, a string, arrays, and the object and classes. And the typecasting, implicit typecasting and explicit typecasting, and why you should be very careful about the explicit typecasting. In short, you know how to store anything in Java. So I believe this session is very helpful for you guys to understand how we'll be doing it. So I want you guys to do one thing. Here is a quick challenge for you. So you guys should declare a variable of your name, age, and height, and whether you like Java, you can also declare it with the Java name. Post your code in the comment section and I'll reply personally. If this helped, smash the like button and hit the subscribe button, and please, please, please don't forget to ring the bell icon for more beginner friendly Java videos. So thank you so much guys, thank you very much. Happy coding.